Man, I love functions. Function is my favorite construct in any programming language. Functions are so simple, so easy to write, so cheap to write. It warms my heart every time I can just write a simple function. I like functional programming because you can just write simple functions everywhere. In the previous video, you have seen one example of a function. Let me remind you. This function just receives a boolean value and convert it to string. You don't have to annotate a function, but I really like annotating my function so I know what I'm dealing with. For example, I'm going to annotate this function. I am telling Rescript that the val is of type bool and the return type is of type string. Since Rescript is an expression language, you don't need a return keyword to return from a function. Whatever that is evaluated last in that function, that would be the return value. For example, let us modify this function a little bit. Remember that if expression is an expression and you can assign it to a variable. And in here, you're returning a different type entirely. Rescript complains that it needs a type string, but you're returning an int. So let's change the return type to an int. It complains that you have unused variable temp, so we can just use underscore to ignore it. You can have multiple arguments in a function. For example, so here you have two arguments, which is attack and defense, and both are type int. If you have more than one argument with the same data type, it's probably better to label it so that you don't get confused. We can also rename the arguments once we label it. Now, what about optional arguments? We know JavaScript often uses optional arguments in functions. Does Rescript have it too? Yes, it does. Wait, what just happened? Rescript complained. This pattern matches the value of type int, but a pattern was expected with matches values of type option A. So the defense argument is no longer of type int, but of type option int. That's why. It's easy, let's fix it. And now we just have to follow what the compiler wants. Cool, it works. Now let's talk about a recursive function. In Rescript, you can also have a recursive function. Before we fix this compiler issue, can we take a moment to appreciate how concise Rescript is? With the switch expression, you can just have very concise pattern matching. Okay, let's fix this issue. It says the value Fibonacci can't be found. That's because for a recursive function, we need to use the ref keyword. We can also have a mutually recursive function by adding an keyword in between the function declarations. For example, so you just need to remember that you need to put an keyword if you have a mutually recursive functions. And of course, you can have more than a chain of two mutually recursive functions. You can have 3, 4, 5. It's not complete to talk about functions in a functional programming language without mention of currying. In JavaScript land, we can curry a function like this. Can we do the same thing in ReScript? Of course we can. But unlike JavaScript, we can choose which arguments we want to supply later. You can use query it one by one if you want, like this. You can use the underscore syntax to indicate to ReScript which arguments you want to pass later. Alright, that's all for function today. I hope this is not too confusing. If you have any questions, please let me down below in the comments. If you like this type of video, don't forget to like and subscribe. I'll see you next time.